Hello everyone, my name is Shaima Al-Maskari. Today I will talk about my paper topic, which is about detection of non-technical losses in power utilities by using machine learning. In this presentation, I will talk about the literature review that is used in this paper, the methodology, implementation, finally the analysis and finding. Not all the electricity that is made by hand reaches to the end users. A significant amount of energy is lost in the distribution system, and there are two types of losses, technical and non-technical losses. The technical losses, which is naturally happen in the transportation, transformation and distribution, and non-technical losses, which is non-natural losses, which is consumed but not invoiced, and it causes in the error by error in the metering or billing, or also by the illegal connection because of the behavior of the customer. The technical losses are determined easily, but the non-technical losses is difficult to predict. There's many impact of the non-technical losses. Economic impact due to loss of revenue, and also there is effect in the performance of the appliances. It causes variation in the voltage because of the overload, and also it affects the government. It affects the investment decision, especially in the undeveloped region, and also it affects the society because of the illegal connections and manipulation of the network, and also the meter tampering are harmful. So there are many research projects of the non-technical losses in Oman. It is in the initial stage, and it is not fully effective in Sultanate of Oman. And also the way that is used now to detect the non-technical losses is costly and time consuming. On the other hand, many electricity companies, they use the smart meter, and this smart meter come up with the new and creative technologies that can be used to identify the non-technical losses by analyzing the data that's collected from the smart meter. So the value of these technologies is due to the increase of the efficiency of estimation algorithms and classification of users. So the goal of this research is to align the electricity companies with the Oman's 2040 vision, and also to study the effectiveness of the machine learning algorithm to detect the non-technical losses. So based on the annual report of one of the leading electricity distribution company, which is Muscat Electricity Distribution Company, due to their to its annual report, it achieved the reduction the distribution losses from 17% to 7% from 2009 to 2020, and they goal to reach 5% losses using the new technologies. Also, the result of this study can be used by the electricity companies to reduce the wastage of the resources, and also to highlight the anomalies in the meter reading. The literature review that is used in this paper is focused on three parts: features, selection methods, imbalance issues, how they solve it, and also the machine learning algorithm. This table summarizes the all paper that is used in this paper. There is different number of customers that use in many papers. They also different type of data. It is monthly, daily or hourly data, energy consumption data, and also there is many feature selection features algorithm that is used, and also many machine learning algorithms that is used and compare between each others, and also there is many matrix evaluation methods that is used to evaluate the performance of the machine learnings. The methodology part, this graph, this figure shows the data flow diagram that is used in this paper. First, this paper used the monthly energy consumption of 13 months of each account. This data is clean and pre-processed, and features are extracted from this data. Then this monthly energy consumption is combined with the static data of the customer profile, and then convert the categorical features to binary, and then features are selection, because there is a lot of features that is extracted. It's better to select the best feature that is related to the anomalies to improve the performance of the machine learnings. And then because of the imbalanced data that is used, there is many ways that is used to balance the data and also to split the data for testing and training sets. And then after solve the imbalanced data and split the data, it's fit to the machine learnings. We use three machine learnings: XGBoost, ANN, and KNN, and then evaluate these machine learnings using accuracy, AUC, and recall, and then check if the performance of this algorithm meet the standard that need to reach. Then the list of customers with the probability to the anomaly or normal is listed. The data collected in this paper is from one of the leading electricity distribution company in Oman. There is three types of data: monthly consumption data of 13 months from May 2020 to May 2021, and also the customer profile data, for example zones and tariff, and also list of anomaly accounts which caused because of tampering and meter faulty and meter stop. The data is then clean from it have a lot of duplication, and prepaid account is clean from all of this, and it's filtered because we need the data of 13 months, and there is many account that doesn't have the full data of 13 accounts, so we filter the data and use only account that have 13 months, and also the account that have less than 11 estimated months. Then the feature is extracted. There is 5 types of features: the raw consumption, which related to the features of the consumptions related to the consumption data; consumption changes related to feature that compare the customer consumption with the of the two periods, the ratio between customer consumption of 2 periods; and then consumption curve, which compare the customer's consumption with the average consumption of the same period; and also consumption anomalies, feature that calculate the number of outliers; and also the features that related to the static features, for example related to the account profile. 34 features are extracted from the data row. This table summarizes the features types. For example, the raw consumption, for example, minimum and maximum consumption; the consumption changes, for example, the consumption ratio between seasons; the consumption curve, for example, the ratio of customer consumption with the average consumption of customers with the same zone and tariff; and also consumption anomalies, number of Z-score and IQR outliers; and also use static features, tariff, for example, tariff and zone. The final data set that is got it from the cleaning, after cleaning and filtering, 248 accounts, and 2 types of accounts: residential with 81% and commercial with 19%, and 3 types of zones with approximately same number of accounts in all 3 zones. In the implementation, there's many steps in the implementation. First, convert the categorical features to the binary using one hot encoding, and then select features using Pearson's correlation coefficient, and then try to optimize the parameters that use in the machine learnings using grid search cross validation, and using the machine learning and resampling data to solve the imbalance data. First, convert the categorical feature to the binary using one hot encoding, and then select only 10 features using Pearson's correlation coefficient method, which feature that's related strongly related to the anomaly account. And then we use 3 machine learning: KNN, ANN, and XGBoost, and then use grid search cross validator to optimize the parameters that can be used in the machine learning. This table summarizes the parameters that used in the machine learning and the range, and the method grid search cross validator get the best value of each parameters for XGBoost and ANN and also for KNN. For the splitting and resampling the dataset, we use 3 steps. First, we oversample it using SMOT, and then first split the data in training and test split, and oversample it using SMOT. The second step is split the data using certified k-fault cross validator and oversample it using SMOT. And the third step is combine between oversampling and undersampling. Oversampling using SMOT and undersampling using random undersampler class, and split the data using certified k-fold cross validator. The first step is first split the data using train test split by 60% for training set and 30% for training set, and then oversample the training set using SMOT method, and then fit to the machine learning algorithm. This figures shows the data set after oversampling. The first one shows the blue data is the normal and orange is the anomalies. The second, after oversampling, it shows that the oversampling, the anomaly is number of anomaly accounts is increased. It have the same number of the normal accounts. The second step is oversampled by splitting the data to using certified k-fold cross validator. First, we split the data. We split the data to number of disjoint subset. Split the data in number of disjoint subsets, and then each subset except one of them for testing, all of them except one is oversampled using SMOT, then fitted to the machine learning. The performance of this way is calculated by calculating the average of each subset. After oversampled, we calculate the average of each subset after fitted to the machine learning algorithm. The third step is combining the undersampling with oversampling and splitting the data by using certified k-fold cross validator. First, split the data in disjoint subsets, and then apply the oversampling the 10% of to have 10% of the majority class, and then undersample it to have 50% more than the minority class, and then we fit it to the machine learning algorithm. In the analysis and finding, we find that the first way, after oversampling and splitting the data in training and test split, we find that the ANN overperform the KNN and XGBoost in the AUC and recall. In the second way of the oversampling and splitting the data in certified k-fold cross validator, also we find that ANN overperform the two machine learnings in AUC and recall. And the third way, combining the oversampling and undersampling by splitting the data in certified k-fold cross validator, we find that ANN overperform the KNN and XGBoost in AUC and recall. This result will try to compare between using all features and also only use 10 features, and we find that using the 10 features is better in the performance than using the all features, especially for ANN, because it shows that using ANN shows low performance than using 10 when using 10 features it shows good performance. At the end of the result and data and analysis, we find that ANN outperformed the other machine learnings, and ANN got the best performance in the oversampling using SMOT, and also in using the splitting training and test split with 85% of AUC and 70% of recall. XGBoost get the best in AUC using the third method, which oversampling and undersampling with 83%, and got the highest recall and using the first step, which is oversampling by splitting training and test split. The KNN get the worst result in this paper. And also we find that minimizing the number of features plays a good role in increasing the performance of the algorithm. And also finally we find that the ANN, with the splitting the data in train and test split and also using 10 features, can help to detect the non-technical losses. At the end, the non-technical losses is a primary concern for the many electricity companies, and it affects the company's profit. There's many literature reviews that use in this paper, and implementing and testing using the real smart meter of residential and commercial customers is used in this paper by using data from one of the leading electricity distribution companies. The data is clean and processed, and the paper use the final number of account is 48,000 account, and 34 features are extracted from the data. And also 2 ways that is used to split the data, using train test split and also using certified K fault cross validator. And also there is 2 ways of oversampling. There is to solve the imbalanced data using SMOT for oversampling and using random undersampler to undersampling the data. Using ANN and XGBoost and KNN as a machine learning, and we find at the end of the result that ANN outperform the 2 algorithms by using the train test split and using oversampling, using SMOT, and using 10 features. By it got 85% of AUC and got 73% of recall score. So by using this, the estimated probability of having anomalies of the meter can be gotten, and the list of customers can be gotten of that have anomalies, if it have anomalies or not. At the end of the presentation, thank you for your listening and for your attention.